Welcome to lesson number 5. We're going to be looking at multiplication of polynomials, part 2. In this lesson, we're going to be multiplying a binomial by a trinomial. So a polynomial with 2 terms and a polynomial with 3 terms. So a rectangle is length 5x plus 2 centimeters and a width of x squared plus 2x plus 1 centimeter. We want to determine the area of the rectangle in centimeters squared by completing each of the following solutions. First of all, we want to find the area, and that's equal to length times width. And so 5x plus 2 times x squared plus 2x plus 1. First way we can solve this is with a diagram. We can use an area diagram, which if you recall using with multiplying 2 binomials, it looks something like this. Now, the only difference is we have one more row because we have a trinomial that we're multiplying here. So x squared times 2x positive 1 and 5x positive 2. Now we would just multiply each of these terms. So 5x times x squared would give us 5x cubed. 5x times 2x would give us 2x squared. 5x times 1 would just be 5x. And then we would have 2x squared, 4x, and 2. So if we simplify this, we would have 5x cubed plus 12x squared plus 5x plus 2. And so we got something with 4 terms. We can also use the distributive property. Using the distributive property, I would go 5x times x squared, which gives me, or actually, if let's see how we did it in this example. Okay, I see. So yeah, distributive property still. They went 5x, and then they just went 5x times everything inside, and then the 2 times everything inside. So my trinomial. We would again get 5x cubed plus 10x squared plus 5x. And then over here I would get 2x squared plus 4x plus 2. And when we simplify this, we end up with 5x cubed, and then my 10x squared, and my, oh sorry, that should be 2x squared, would be 12x squared, and then my 5x, and, oh, and there's a 4x there, so sorry, I made that mistake earlier, would result in 9x, and then positive 2. Now, we're going to do the same thing here. We're going to expand and simplify like we did above. So if I expand this, then I'm going to multiply my x squared, first of all, that first term, by my trinomial, 2x cubed plus x minus 5, and my second term by my trinomial as well, 2x cubed plus x minus 5. We're going to get 2x to the power of 5 plus x cubed minus 5x squared, and subtract 8 x cubed minus 4x positive 20. And when we simplify this, we're going to end up with 2x to the power of 5. And then I have my x cubes here, minus 7x cubed, and my x squared, minus 5x squared, minus 4x plus 20. And we're going to expand and simplify this large polynomial here, where we have 4 times a minus 4, a squared minus 3a minus 6, and negative 4a minus 3 times 4a plus 3. Now, first thing we want to do is do exactly what we were doing up here, but afterwards we'll multiply by the 4. So I'm going to use square brackets, just showing that I'm going to be taking care of this and this first. And actually, I can take care of this afterwards, so I might put this in its own set of brackets. So I have my a times a squared minus 3a minus 6 minus my 4 times a squared minus 3a minus 6. And this is where I'm going to close that square bracket. And then I'm going to subtract this, and this is a difference of squares here. So this is where I can just say 16a squared minus 9. And I'll subtract that afterwards. So I can deal with what's inside my innermost brackets here. That's going to, if I just use distribution, a cubed minus 3a squared minus 6a. So I want a times that 6 minus this set of brackets here minus 4a squared plus, and I don't really need this bracket here actually, so I'm just going to cancel that out, plus 12a plus 24. And then we're subtracting 6a squared, positive 9, if I distribute that negative sign in. Now I can multiply everything in here by this 4. That will give me 4a cubed, so 4 times a cubed, minus 12a squared, minus 24a, minus 16a squared, plus 48a plus 96, minus 16a squared plus 9. So a lot of terms that we're dealing with here. This is where it's good to use these arrows so you don't get confused about what you're multiplying and distributing. But now we can gather our like terms. So 4a cubed. Now let's look for our squareds. 12a squared, negative 16a squared, negative 16a squared. It results in negative 44a squared. I add those all together. Now I have my a value, so negative 24a plus 48a would be positive 24a. And then lastly, our constant terms, 96 plus 9, we get positive 105 as a final answer. For this last example, we're going to be looking at the volume. So consider this rectangular prism, and we're multiplying three binomials, the product of 3 binomials here. So we want to write an expression which represents the volume in centimeters cubed. So volume is equal to length times width times height. Therefore, volume is equal to my length, which is x plus 1, my width, which is x plus 2, and my height, which is x plus 5. And that's in centimeters cubed. Now, if I expand it in this form, volume is equal to ax cubed plus 5bx squared plus cx plus d, then all I'm doing is I'm multiplying all my binomials by one another. So I'm gonna begin by just taking care of these two here and then multiplying it by x plus 1. So x plus 1 times x plus 2 times x plus 5 would be x squared if I multiply those, plus 5x plus 2x plus 10. And this is equal to x plus 1 times x squared plus 7x plus 10. And this comes from combining these like terms here. Last, I'll approach it like I did in the earlier problems. So x times x squared plus 7x plus 10 plus 1 times x squared plus 7x plus 10. So if I distribute this x into my inside polynomial, I'll end up with x cubed plus 7x squared plus 10x, and then I'll just add my other polynomial that I multiplied by 1 and got the same thing. And this results in my volume, which is x cubed plus 8x squared plus 17x plus 10 centimeters cubed.